Hello and welcome, guys. That was our introduction done in dog. If your dog heard that, he or she is probably running to the backpack to get out their notes for the video. And where are your notes? Why aren't your notes out? Your dog's got your notes out before you. It's a shame. Okay. Welcome, guys, to another episode of SIP Zoyas. Let's go ahead and dig into the curriculum. So today we're going to be talking about completing the square corollaries. And basically what this is going to be, it's going to be consequences that come from completing the square. We're going to make some observations on the completing the square process and the outputs that it gives us, and be able to extrapolate some conclusions from this, kind of come to some bigger conclusions. So the conclusions, of course, that are going to come from this are about the vertex, solutions, and the quadratic equation. Spoiler alert, the quadratic equation comes from completing the square. It's actually very magical, and if you can prove it, if you can go from standard form to the quadratic form, you can earn yourself 20 Z-Bucks. Oh yeah! So let's go ahead and start talking about this. So first off, we're going to talk about finding the vertex. So notice when completing the square of a quadratic of format x squared plus bx by adding quantity b divided by 2 squared. So realize, right, when we're completing the square, when we realize that's the secret square value, that we add it, and then we can factor it into this. Right? Our result is consistently this. Right? So we're going to notice this, and we're going to draw a conclusion from it. Notice how this format allows us to determine the x value of our vertex. Right? Why does it do that? It then creates a single x term which can be zeroed out. By zeroing out this x term, we are then able to realize what the x value of that vertex would be. So thus, the x value of the vertex is always negative b divided by 2, when a quadratic is of form f of x equals x squared plus bx plus c. And realize this is true since this value is the value that will zero out our x term. Okay, realize we plug this into here, it's going to be the opposite of b divided by 2, right? The opposite of b divided by 2 is negative b divided by 2, so no matter what, right, we notice we have this format and we go to here. It's always the next step. Once we're here, we then realize this will always be the term to zero this out. Ergo, this will always be the x value of our vertex. Okay, so this is going to be the x value of our vertex. And now, so realize, right, once we have our x value, once we have that x value, we can then go and find the y value. Right? How do we do this? You may already know. The y value of the vertex can then be found by plugging the x value of the vertex back into the function, where we have f of negative b divided by 2. Right, so remember, this is our x value. We then take it to find the y value and plug it into here. So say this is our function, right? We find our x value for our vertex. Well, we know that's associated with the vertex. So if we find another point, if we find the y associated with that, that must be the y value for the vertex. So we can go ahead and plug negative b divided by 2 back into our function to then get out our y value. Okay, this isn't saying what it's equal to, it's just saying that when we plug this back in, whatever it is equal to will be our y value. Okay, so now let's go ahead and put it all together. Thus, the vertex of quadratic form f of x equals x squared plus bx plus c. And side note, really quickly, so we see that it's plus c right here, and we're not used to that in our format up here, but that's okay. That's okay because we're choosing to focus right here. We're choosing to focus on this bit, which we complete the square with. This plus c we can actually completely ignore when we're completing the square. We can add in the square like it's not even there, do our thing, and this plus c will still be there on the other side by the time we're done completing the square. So when we have a quadratic of this format, again, the c is almost, I want to say extraneous. I'm not sure if that's the right word for it, but it's almost irrelevant. Our vertex, when we're in this form, is negative b divided by 2 quantity f of negative b divided by 2, right? This negative b divided by 2, which zeroes out our x, and then that quantity plugged back into our function. Right? And this is going to give us our vertex. Now, one very, very small note. So note when a quadratic is of this form, so right now we have an a right here, say that it's not equal to 1, and say we have a different number right here that is a. We don't know what it is, but it's not 1. It's going to make a slight modification to this. Right? And here's going to be the modification right here. And this is just due to having to divide by a before we can go ahead and get it into this format. Right? Imagine that if we had an a right there, right, we have an a right here, we can divide both sides by a to then get it into this format. That's going to then give us b divided by a for this value right here. So then we just do b divided by a divided by 2, which is going to give us this. Okay? So here's the secret sauce, right? Here's the corollary. We go ahead and realize that this is always going to give us our vertex, and it allows us to realize it without completing the square. We realize that no matter what, when we do this, it will always get us to this point. So we can then just look at this, find out what our vertex is, and move on. Save ourselves a bit of time. So note, when a quadratic is of form, and so yeah, like I was saying, note when we have this a right here, realize it's just going to be included down here. And you can actually even experiment, right? Imagine if this a was equal to 1 and we plug that in, what would happen? Well, it would actually just turn right back into this, right? Because if a was 1, b divided by 2 times 1 would just turn back into this. Okay? So if you really want to, you can actually think of this as more the general formula, the general corollary which we are drawing. But also understand you can easily just divide the a over by yourself to get it so there's no value there, and then go ahead and proceed with this format. Either one could work. Two ways of talking about the same thing, two slightly different approaches to the same problem. So now let's go ahead, let's test this out. We're going to be looking for the vertex on these. Okay, so we're going to look for the vertex on these. And so let's go ahead and start off just by labeling these A, B, and C, right? Because this is the standard format of our equation, right? So we have our A right here, which is going to be equal to 1. We have our B right here, which is going to be negative 12, and our C, which is going to be equal to 46. Okay. Now we know that once we have it in this format, and it's actually in this format, so we don't even have to include the A, which is equal to 1, that we can just go ahead and plug it into this. Okay, so our vertex is then going to be, and let's write this general equation, this general extrapolation, negative b divided by 2, comma, f of negative b divided by 2. Okay, and honestly, I would actually recommend memorizing this one, just because it's going to cover more cases than this one would. You don't have to worry about dividing the a over before you do this, where this is just going to take it into account. But you know, it's really up to you. It really is up to you. Okay, so this is our vertex. Now let's go ahead and plug in our b. So b is going to be negative 12, right up there. So we'll have negative of b, which is negative 12, divided by 2, and then f of negative b, and remember b is negative 12, divided by 2. And this is going to be our whole vertex. So let's go ahead and start calculating this. So this, of course, our x value is the easiest. Right? So we're going to have a negative of a negative, which is a positive. So 12 divided by 2 is going to give us 6. So the x value of our vertex is going to be 6. And now let's go ahead and we'll do some side work over here to calculate what this is. Right? Because we have f of negative 12 divided by 2, we just know that's 6. Because remember, we're taking our x value and now plugging it back in to find our y value, would equal. And now we can just go ahead and substitute this 6 in for where our x's are, right? Remember, this is a function, and although it's not notated as a function right here, that's really what it is. We can write f of 6 and just plug in 6. So we're going to go ahead and do that, equals 6 squared minus 12 times 6 plus 46. Okay? Now going ahead and evaluating this, doing the calculations, 6 squared is going to be 36. Negative 12 times 6, that is going to be 72, a negative 72, plus 46. We can then go ahead and start adding these. So we're going to have 36 minus 72. So that would be, doing some quick mental math, that would be, I'm drawing a blank. Be 30, negative 36. Negative 36 for that. Yeah, that makes sense. Oh wow, that was actually way easier than I made that seem. Plus 46. And negative 36 plus 46. Side note, this is where you can just use your calculator. I'm just trying to buff up my calculation skills, so I'm doing this by in my head. So going ahead and then doing this math, negative 36 plus 46 is just going to give us 10. Okay? And so then that means f of 6, or f of negative 12 divided by 2, is going to be 10. So this is our vertex right here. Okay? Recap. What we did was we found the x value. We knew it must be this based on the pattern we recognized in our completing the square method. We then take that, plug in our x value, right, or put it in for our vertex, and then take this x value and use it to find our y value, which we calculate right here after substituting it into our equation and then writing it back here. Okay, and that's our vertex. Okay, next one. So, now I approach this and I immediately recognize something about it. And what do you think I recognize? I recognize that this is not in standard form. And I recognize that the pattern I noticed requires this to be in standard form. So I'm actually going to go ahead and take a second to write this in standard format. So I'm going to go ahead and isolate y by subtracting it over. Then I'm going to have 6x squared plus, oh, sorry guys, a little bit of an itch in my throat, plus 13 equals negative y. Okay? And then, you know, we do have y on its own, but let's go ahead and get rid of this negative by dividing by negative 1. Remember, that's going to divide everything, so we'll have negative 6x squared plus 12x plus 13 equals y. Okay, so this is our function right here, right? This is our equation. I'm going to go ahead and put 2 stars next to it just so I remember that this is my equation. And now we can use this, it is in standard format, to go ahead and notice and apply this pattern that we noticed. Now, from here, there's one of 2 ways of thinking about this, or one of 2 ways of doing this. You can either go and you can take it just like this, and use this format where we have a right here, and we would realize that a is negative 6, and then we can go ahead and plug it into here, and just go about it accordingly. Or we can take a second, this is the way I'm going to do it, to divide both sides by negative 6. To get rid of that, so that way I'm matching this format. Okay, and side note, it doesn't matter. Realize either one's going to get you to the right answer. I think you should choose the one that either makes the most sense or is most reliably produced for you. So I'm going to choose to go back to this. This is kind of my home base. This is very easy for me to think about. So I will divide both sides by negative 6. I'll end up with x squared. Oh, and I just noticed a small mistake. This negative was not divided to every single one. That is it's a little typo. I forgot to write that. So that that's actually a negative, and this is a negative because I forgot to divide the negative to these two terms. So now we're going to go ahead and divide everything by negative 6. So that's going to get rid of this negative 6 multiplying x squared. We're then going to have negative 12 divided by negative 6, which will produce a plus 2x. And then negative 13 divided by negative 6, that is nothing pretty, but remember, that's okay because this is our constant term, and we can actually just straight up ignore this when we're completing the square. It's not going to have any effect on the square that we complete. So it's okay, right? That's weird, but that's okay. It doesn't need to be not weird, or it doesn't mean we're going to have some weird calculations in front of us. Alright? So, I got it to this format. I'm now going to go ahead and find b. Right? My b is 2, and so my vertex, right, using this general form up here, it's going to be negative b divided by 2, comma, f of negative b divided by 2. And realize it is this format because I divided by negative 6. I can't emphasize this enough. I'm only able to do this because I got the coefficient in front of my x squared term to equal 1. So this is what it's going to look like. So I'm going to have 2, which is b, negative 2 divided by 2, comma, f of, comma, parenthesis, negative 2 divided by 2. Close parenthesis, close parenthesis. And this is my point. Okay, now of course I want to go ahead and simplify this, so that's what I'm going to spend this next little bit of time doing. So negative 2 divided by 2 is going to be negative 1. And that's our x value. So negative 2 divided by negative 2, that's going to be f of negative 1. And realize, so now we want to go ahead and we want to calculate this, and what this is saying is, what does y equal? What does our output equal when we have a input of negative 1, a x of negative 1? So I can go back over here to my equation, and I can then just go ahead and plug in negative 1 into there. So, doing the calculations down here, f of negative 1 is going to equal negative 6, quantity negative 1 squared, minus 12 times negative 1 minus 13. Okay, going ahead and calculating this. I have a square term. I'm going to calculate that first, right? PEMDAS, please excuse my dear Aunt Sally. Negative 1 squared is going to be 1 times 6 is negative 6. Negative 12 times negative 1 is plus 12, and then minus 13. Okay, negative 13 plus 12 is going to be 6. 6 minus 13 is going to be 7. And actually a negative 7. Right? Negative 6 plus 12, that brings us to 6. 6 minus 13, right? That's going to be negative 7. Okay? So that is our y value. We can go ahead and then plug this back in to finally get our vertex fully simplified and everything right here. Okay? Now, quick check. How can we know this is correct? How can we double check this? Well, you can do one of two things. A, you can go ahead and complete the square to verify that yes, indeed, this is your vertex. That's a little bit lengthy, and so if you already did this work, you may want to save a little bit of time. You can then go ahead and use your calculator to then find out what the vertex is going to be, and it should line up with this. Alright, going on to the second topic. So, another corollary which comes from completing the square, right? Completing the square, corollaries, it's a nice phrase. When finding the solution by completing the square for a quadratic form of f of x, standard form, right? This is just standard form. When finding the completing the square for a standard form quadratic, the yielded result is always x equals negative b plus or minus square root of b squared minus 4ac all divided by 2a, the quadratic formula. And this, I can't emphasize how truly miraculous this is. I can't emphasize how, I think for some of you, you may have used the quadratic formula before. But just realize, right, this comes about because of completing the square. Just take a second to take that in. If we were not clever enough to exploit our perfect square equation, this quadratic formula, right, this kind of one-stop shop, just plug in your variables and calculate, would not be here. Okay, it's truly a gem, right? It's a gem that is a product of very clever thinking. So, before we go forward, I do want to go ahead and again put on the table that if you can take this, right, our standard form quadratic equation, and find a way to derive this, meaning that, right, you take this, you complete the square on it, and then you solve for x, and if you do this, it should get you to right here. If you can do this, you will be the owner of 20 Z-Bucks. 20 Z-Bucks. Okay, so go from here to here. Right? Derive the quadratic equation. You're going to earn yourself some major bank. Because it is a great exercise, great for the mind, great for the spirit, and great for your math grade. Okay, so, right, this is the quadratic formula, and it comes from this, and we're not going to show the derivation for it. I want you to try and figure that out, but trust me, this is what happens, and it's always going to happen. So, thus, solutions to an equation of form ax squared plus bx plus c, right? Just this form, we're looking for the solution, so f of x is equal to 0, or y is equal to 0, are going to be this, are going to be our quadratic equation, our quadratic formula. Okay? So let's go ahead and let's use this quadratic formula in all of its beauty and all of its wonder and all of its resultingness from the perfect square method. So plus and minus the square root of b squared minus 4ac. Okay, I'm going to go ahead and write my quadratic formula again, just so that way I'm clear on what it is, right? We never want to forget this. If you do forget it, and side note, I actually never remembered this in high school or college. I just completed the square. I preferred the method over the memory, right? You guys know I don't have a great memory. If you don't want to memorize that, you can just go ahead and complete the square. But you do want to write this down so that way you're straight on it. And on top of it, I think most of your tests, I think they will have this in it. So you'll be good to go. So, okay. So we write down our quadratic equation. We are now going to go ahead and label our variables. This is going to help us, like I said, keep everything straight. We don't want to get any mixing up going here. We want to be good mathematicians, and we want to label everything. So c equals -2, right? Because this is my a, this is my b, and this is my c. How do I know it? It is already in standard form just like this. It is set equal to 0 just like a solution would be. And now I can go ahead and use this to find out what both of my x values are. And side note, notice the plus or minus. Right? We have the plus or minus. How many solutions does that mean we are going to have? So x equals, now I'm going to go ahead and plug in my values of a, b, and c. So -4 plus and minus the square root of 4 squared minus 2ac minus 2 times -3 times negative 2. All divided by 2 times negative 3. Okay? This is the easy route, right? This is pretty straightforward. This is simple, right? We notice our pattern, and then we take advantage of the pattern that we notice. So now let's go ahead and calculate this. And so honestly, I think the real challenge here isn't plugging this in and then calculating it. I think it's simplifying it and dealing with the radical which you may have. And we do want to simplify it. That's going to be part of the problem as well. Right? Sure, we can plug it in, but we also do want to simplify it. And by hand as well, not with a calculator, because we want to find out the integer values of this radical that go underneath this radical. No decimals here. So this is going to equal, let's go ahead and start calculating. So we're going to have negative 4, we're not touching that. Now on the inside we have 4 squared, which is 16, square root, minus 2 times negative 3 times negative 2. Well, I know that these are two negatives, they're going to cancel into a positive, so 3 times 2 is 6, times 2 is going to be negative 12. And then on the bottom, I'm going to have 2 times negative 3. Okay, and as I'm working through this, I already noticed that underneath my radical, 16 is bigger than minus 12. I'm going to not have a imaginary number under here. So I'm already saying to myself, I don't think I should have an imaginary number in my solution. So 16 minus 12, well, looky there. That's going to be plus or minus the square root of 4. That is a nice, easy radical that we can calculate. That's going to be negative 4 plus or minus 2 divided by negative 6. And that's going to equal, well, negative 4 plus 2 is going to be, oof, that's very terribly written. I need to work on my penmanship. Mr. Zoyas, get better at your penmanship. That's going to be a negative 2 up here. And then we're going to have negative 4 minus 2. Let's try and fix that. Negative 4 minus 2, we're going to have negative 6 divided by negative 6. Okay, simplifying these fractions, negative 2 divided by negative 6, they have a common factor of 2. So that would be 1 divided by 3, or 1/3, is the same as negative 2 divided by negative 6. And negative 6 divided by negative 6, well, that's just 1. So these would be my two solutions. Okay, oh, let's scoot this up a little bit. Okay, notice that this calculation under here is very essential. Okay, that's actually going to be a chunk of these problems. Okay, next one. So we are going to do this using our quadratic formula, right? This beautiful little nugget of information which comes from completing the square, right? We think we can call this beautiful, but we know who the real boss is. We know who the real person of credit is. It's the completing the square method, right? That's the true king here. So we have x equals, writing my quadratic formula again so that way I don't forget it. If you're not reciting it in your sleep, you have not memorized it enough times. Okay, you want to know this thing like the back of your hand, or have the math skills to just bust out completing the square whenever you need it. If we have trouble remembering this, I swear, we will do a song. Do not dare me. We will do a song in class if we have trouble remembering this. Okay, so a equals negative 13, b is going to equal 7, and c is going to equal negative 9. How do I know that? I know it because of this format up here, right? This is just my standard format. Oh! And I actually almost made a misstep, right? Because of this format up here, does this match this format? It does not, right? This format up here, this is our standard format, and it doesn't match this. So step number 1, we want to go ahead and convert this into this format. Okay, so go ahead and lightly cross off our mistakes. And now what I'm going to do is I'm going to add 9b squared to both sides. Okay, I'm going to add this to both sides because I want to get rid of this over here. I'm going to add 9b squared to this to get it away from here, over to here, so I have my square term, my linear term, and my constant term all equal to a 0. And that's going to put me in the form to then use this quadratic equation, or quadratic formula. I'm never sure which one it's supposed to be called. Okay, so equals negative 13b squared plus 9b squared. That's going to give us negative 4b squared plus 7b minus 9 is equal to 0. Okay, now we have our matching format. Now we can go ahead and say what a is, we can say what b is, and all that loveliness. So we have a, which equals negative 4. We have b, which is 7. And we have c, which is negative 9. Okay. So now going ahead and taking these values and plugging them into our quadratic equation. B is negative 7. Or sorry, it's 7, so plugging that into b is going to give us a negative 7. Plus or minus the square root. And past my terrible penmanship, that's a b squared, so we're going to have 7 squared right there. Minus 4 times a, which is negative 4, times c, which is negative 9. And I highly recommend just taking a step, devoting a step just to plugging in each of these values until you're a math beast. Until you're like Mr. Zoyas. No, I'm not going to talk myself up like that, but not until you can do these calculations in your head while plugging them in, should you do so. Right? Baby steps. Let the paper do the thinking for you. Let the paper do the memory for you. You're a mathematician. Mathematicians don't remember things. They derive them. They calculate them. Let the paper do the memory. So we have 2 times negative 4. The bottom, that's going to give us negative 8. We have negative 7 up here. Plus or minus, inside we have 7 squared. So that's going to be 49 minus 4 times negative 4 times negative 9. Well, I can tell this is going to be a positive because I have 2 negatives right here. So 4 times 9 is going to be 36. 36 times 4 is going to be... we have 4 times 36, so that's going to be 120 plus 24 is 144. Does that make sense? Does that make sense? That does make sense, because I could factor this into 3 times 3, which would then be 4 times 3, and then 3 times 4, which would be 12 times 12. 12 times 12 is indeed 144. Okay, cool. So, let's go ahead and calculate this. So now, notice, right? Am I going to have a negative under here? Indeed I am. So what's that going to mean about this? I will have an imaginary number popping out here at some point. So we go ahead and calculate 49 minus 144. And that's just going to be 95, a negative 95. Square root of negative 95 plus or minus 7 divided by negative 8. Okay? And then going ahead and factoring out the, or taking our negative, right? We have a negative under the root. Let's go ahead and make that imaginary. So we have 7 plus or minus imaginary root 95 divided by, oh, and look at that, I dropped a negative. Want to be very careful, make sure you don't do these mistakes. Okay, keep an eye on what you're doing. Square root of 95. So let's go ahead and see if we can break down the square root of 95 anymore. So the prime factorization of 95. What can I turn that into? I can divide that by 5, and that would give me 19 and 5. And it looks like we get 2 prime numbers from there. right? 19 is a prime number, and so is 5. So we can't break this down anymore. It actually turns out that this is our fully simplified solution. Okay, just take a step back for a second, realize that this is the chunk of kind of our work, right? Plugging it in is the easy part, right? Remembering this is kind of the easy part that's not math intensive, that's memory intensive. The real math kind of comes in when we're simplifying these. Okay? So, again, one more note, right? We have a third and final way of finding our solutions. Actually, I think it's more than 3. I'd have to go back and think, but this is just yet another tool you can add into your tool belt for finding these solutions. Okay? So let's go ahead. Yeah. And bye.